Okay, here we have ourselves problem 7 from the VFPM practice. This is called launch a projectile at an angle. These get ugly, but we'll see what we can do. So let's pick an initial angle of 30 degrees for a nice number. And let's pick a nice convenient launch initial speed like 20 meters per second. And the question now is, how long will this object be in the air? How far will it go before it gets to the ground? So let's think about the trajectory a little bit. That's the fancy name for the path this thing takes. I'm going to attempt to draw a nice clean parabola. Takes off, goes over, goes up, comes back down. And as we think about that trajectory, the question is, how long is it in the air? Well, a really convenient thing happens up here. At this point, or any point in free fall, that is any point it's in the air, we know that the net force on this object is just the Earth pulling on it. That is, at any point during its motion, we know that the acceleration is only straight down. So the convenient thing is, if we think about up to the top, we also know the Vy, the speed in the vertical direction at the top, is 0, because it stops moving up and down. Of course, what's the Vx at the top? Well, whatever velocity it started with, of course, we drew it as 20 meters per second, but that has parts, right? That has a horizontal part and a vertical part. So if we think about this as a horizontal part of 20 and a vertical part of 20, whatever that horizontal vector component is, up at the top, it's going to have that same thing. So the velocity x at the top is going to be the same as velocity x at the beginning. That is, all the way through this motion, the horizontal velocity remains the same. Go back and watch the initial projectile review videos if that's helpful. So in other words, we can tell that that velocity horizontal stays the same, and we can also decide how much time it takes to get to the top. Let's go ahead and find these parts. So this is the adjacent side, so the horizontal velocity initial is 20 meters per second times the cosine of 30 degrees. And the initial velocity vertical is 20 meters per second times the sine of 30 degrees. So I'm going to grab my calculator and figure those out. Okay, so with the calculator I recognize 20 times the cosine of 30 is 17.3, that's the horizontal speed. 20 times the sine of 30 is 10, because of course the sine of 30 is 1/2, so that's the initial vertical speed. So here's a convenient thing. This object starts going up at 10 meters per second. I wonder how long it's been until it gets to the top. Let's think about our vertical distance equation for just a minute. Vf is Vi plus At, and you can use that as a tool if it helps to think about it mathematically, or you can just think it through too. What's the final speed if we think of this vertically, and we just think about the interval that ends at the top and starts at the launch? Well, the final speed vertically at the top is 0. The beginning speed is 10 in the upward direction, and we know g in this case is 10. We're going to call it negative 10. I'm going to make positive v up, so g is negative 10 meters per second squared times t. Well, what's convenient about that is that tells us that t, if we solve for t, is 1 second. That is, it takes 1 second to get to the top. Well, that means if we're going all the way to the bottom and this thing is nicely symmetrical, the t, when it gets back to the ground, is twice that, 2 seconds. And then, if our question is to find, well, time in the air, 2 seconds, we got it. And the range, well, the range is just distance x when it gets to the ground. Well, if we put in our nifty equation again, we write out everything we know. What's the final distance? Well, it's the initial distance plus the velocity initial times the time, that's an x, plus 1/2 at squared. That is, I'm writing out the same equation that I use all the time. But then I'm going to go back here and notice a whole bunch of this stuff goes away. Let's choose to call our beginning location 0, 0. Let's call that a coordinate point 0, 0. That's going to make this term be 0. The initial velocity x, we know that it's 17.3 meters per second, so we know that number. The time in the air, 2 seconds, we know that. the x acceleration, hey, it's a projectile. AX is 0 meters per second squared. Of course, AY is g, in this case negative 9.8 meters per second squared in the downward direction. But in this case, AX happens to be 0. So in other words, this comes down to just how far does it go? Well, just velocity times time. So 17.3 meters per second is the velocity, times the time, total time in the air, 2 seconds, and from there we've got it. 17 times 2 is 34. This must be 34.6 meters as our range, that is distance x final. So there is a quick run at a nice symmetrical angle launch projectile problem.